Good morning, everybody. Thank you for the nice introduction and the invitation to be here today and to share some of our results from a research project or a research period of, I think, about approximately 6 years. And yes, today it's an honor for me to represent the Institute, and the research group is working on that. And yes, it's a funded project, it's a national funded project. In Austria it is FFG, and we work close together in this project with industry partners. Yes, and it's super nice that Georg is accompanying me today. So if there are questions that go deep into the topic, then we are together here to answer your questions. Yes, for today, I would like to present we try to give or to name it the Grazer Stahlbeton-Leichtbauweise, or lightweight reinforced concrete slabs. And it's the story about a dissemination process from research to clients and industry partners, and how we can work together to bring these ideas that we deal with, all of us, that we try to contribute with digital fabrication, additive manufacturing, structural design, and architectural design to improve or to change our construction thinking in the next years. From the additive manufacturing side, so we started in 2017, and we came up with our own material mixture. We built our own printing nozzle for this extrusion process. Then we changed and did some tests with concrete and cement-based foam. And in the end, we ended up with this inside prefabrication of slender prefabricated elements that we use as a lost formwork. And this was the challenging question about material and process. And the other hand is how we can contribute to the question of this enormous amount of material that we use in our everyday construction sites and the infrastructure building that we need. And we know this is everyday life. So thousands of square meters, approximately 5 million square meters every year in Austria of concrete slabs that comes up new. And we also knew from our last speaker that there is not the amazing change of technology over the last 50 years. So we do it quick, fast, safe, but it's material consuming. And when we have a look into material and the material use for residential and office buildings all over the world, it's significant that in Europe we use an enormous amount of concrete, but all over the world for office building we do the same. So it's a global question, but we can contribute as a local group of designers and local material distributors and construction industry. And this was our first guess or hypothesis that we would like to change plates and slabs for floors, reducing and take out material up to 40% with the method of this ribbed Kassettendecken. And it was the idea that we can keep the height and that we keep the performance, and that we can take out just the material. As a first guess, it was reduce the self-weight by 40% and keep the performance as it is, taking the same height. As a first result of our research project, I've 3-year lasting one, we came up with this prototype and this demonstrator. And we looked back and took the design of Pierluigi Nervi, so it's well known, and cut it out, this piece of element, optimized this rib slab with the goal that we do a bigger prototype that we can test in our lab. We produced all these elements in our Roboter Design Labor. And prefabricated this testing piece together with our partners from industry. Did the reinforcement work, and here you can see that there is some effort in this reinforcing of the ribs, and then we poured in normal concrete to get the strength. And as a result, we could demonstrate that we reduce an amount of concrete. This is the white block. We have the same amount of steel reinforcement, and there is an additional amount of CO2 equivalent brought into the construction by this printed concrete. So we should never forget that this is high quality concrete, high strength concrete, and it's approximately the double of amount of cement in this mixture. And outgoing from this demonstrator, we got the opportunity for a first design proposal for an artist, Hans Kuppelwieser, and an atelier in this castle in Upper Austria. And again, we did this design part for a 10 by 10 meter atelier room, 100 square meter, and it was, together with the artist, a process of finding a ribbed design and solution, and we came up with this proposal here. We did all the structural calculation and optimization process, and in the end we did all the print path generation and the production in-house. And you see the quality of the printing material, the quality of the surface is changed. So it's our partner from industry is Baumit. So this material industry, the bigger one in Austria, and their department for 3D printing is working with us close together and do a lot of funding for all this work here. And all these elements in the end find their place at the scaffolding, and we had a lot of effort in reinforcing all the ribs. It was some nice struggle to be there for 2 weeks at the construction site, and in the coffee break, you can ask Georg about some stories about working in this wonderful site there. But in the end, we came up with this Rohbau view shortly after the scaffolding was removed, and now it's a place for art and art pieces, and we are happy that we could contribute in this project. But as a result, concerning sustainability, you can see here that we again removed some concrete material compared to a flat plate and slab, that we could reduce the amount of reinforcement, and there is another, again, some more CO2 equivalents coming out of this printing material. And we see here that working together with the client, the engineers, research, and the industry brings things together, and we got a lot of information, a lot of questions out of this project again. And some of you know this project again with a client that is working together with Permit. So it's a smaller construction company in Bavaria. They own their own printing facility, and we come together to, to contribute to lightweight structures and think about and had a discussion about how we can bring that into the construction site there. And it's a roof over a garage, and it was the question how we can take out material to make it to a lightweight concrete solution. Here you can see Graz contributed. It was Engelsmann Peters' office, Baumit GmbH, eigener Bauunternehmer, so he was the man. He did it in the end, and Merker Transportbeton. And all together worked hard to bring that to real. And our part was the design again. And here you can see that it's a single-span cantilevering structure, and we came up with this kind of a canoe-shaped design. And we did all the pre-tests for printing strategies, but in the end, the construction company did all the printing. So it was the transfer from research to industry or to the construction company. And they had the facility quite close to the construction site. Again, it was the assembly process that in this case it was pretty simple to do that, and the reinforcement and additional concrete work that has to be done. And again, we did some calculation about the resource efficiency and the CO2 equivalence, and you can see here that we came closer to a goal that we can reduce CO2 equivalence by a rate of 40%. And why is this possible? So we reduced the amount of concrete. We used different concrete, so it's binder reduced, cement reduced concrete as the poured in concrete. Again, you see in magenta the amount of CO2 equivalents coming out of the printing material. We took out the inclination insulation part, and we reduced in a bigger amount the reinforcement that is needed for this roof construction. Yes, and we are proud and happy that today we can go for Düsseldorf to gain the German Architecture Concrete Award for this project today. And that means that concrete printing and additive manufacturing bringing into construction will be honored in Germany, and that makes us happy to be there with all the team that was responsible for this project. And it was possible in this constellation to do another building. It's Berit Werkhof in Vorarlberg, Austria, Bludenz. So it's approximately 800 square meters, and it was a similar constellation. So there was the architectural office Atelier Ender. It was GBT, Ziviltechniker engineers. So the planning team was existing, the design was done, And the Tomaselli Gabriel Bau construction company owns the concrete 3D printing company. These two together with the material provider Baumit asked Institut für Tragwerksentwurf for contribution to make this roof lighter as a lightweight structure, and we could step in and give some support to change the construction for this ripped solution, and we came up with this around 800 elements that are printed and placed for this approximately 700 square meter roof. And all the elements are different and find their place. And you see all the reinforcement work that is now better and better and more efficient. And we are happy to show you the result for this integration of 3D printed hybrid structures that are lightweight and can contribute to the questions of sustainability as well as additive manufacturing. And again, we did this post calculation for the CO2 savage, and you see it is a span of 40 meters, as higher a span as more efficiency we can gain. You see this white column is the reduction of the amount of concrete that is poured in. The blue one is the reinforcement that could be reduced. The magenta one is the additional CO2 equivalent coming out of this printed material. And so it was not possible to use binder reduced concrete for the additional poured in concrete. But if it would be, if we could manage that, it would be possible to reduce the amount of CO2 equivalents by around approximately 40%. All these four projects together summed up around 60 tons of CO2 equivalent, and take them out of these concrete slabs. And all these four projects asked a lot of research questions that came back into our research projects. It was about a lot of printing tests and printing strategies, how we can manage in a safe way these lost formwork pieces. Here are some of the tests for the Nördlingen project. It was the big opportunity of testing one-to-one scale about the mechanical properties. This was from the first Quebo project. And we worked close together with the Department of Civil Engineering and their testing facilities. And the same was done for the Nördlingen project, that we could cut out one piece, produce it in the place, bring it to our testing facility in Graz, and do this one-to-one scale test. But it was not only about the question of strength, it was about fire resistance. So we did a first one-to-one scale test of 1 square meter that gave first answers about the bond between the printed concrete and the poured in concrete. And you can see here the results, that is a perfect bond, and the fire resistance of this printed concrete is super high. And of course we did tests about the bonding between the two materials. With these small scale tests. And additionally, we did Carbonatisierungstests for printed concrete together with this poured-in concrete to get first information about these properties. Concerning the fire resistance, it was possible in this project, in this research project, to do bigger one-to-one scale tests of one of these slabs. So we produced it, and it is loaded and under fire for more than 120 minutes, and it's full resistance for all the needs for fire resistance. It is REE 120, and that opens the field that we can use this kind of slabs for residential and office slabs as well. And so I cannot show it now, but so we do similar tests for acoustics, that we get the answer what is the best way of floor design for this kind of slabs. Yes, coming to an end, we do that in a bigger group that I can represent today. On the left side is the printing group. It changes all the time, but it's a small group of architects, civil engineers, material scientists, and industry together that work on these questions. On the right side, we founded a research center for sustainable construction at the TU Graz that helps us a lot to answer the question about sustainability in construction. And it was one goal not to design research pavilions in this project, but finally we did it. And I can show you first pictures and first two slides of a research pavilion about 10 by 10 meters, again 100 square meter, in the place of Baumit industry in Niederösterreich, close to Vienna. And it was the opportunity to use this idea of lost formwork for walls and slender columns again. So we know a lot about these grids for the slabs, and now we have to do first steps into other kind of structural elements. Yes, thank you for listening. If there are any questions right now, feel free to ask, but we can do it during the coffee break as well.
Thank you so much for this really nice presentation. We have one question.
Thank you very much for this wonderful presentation. I have one question about the printed concrete of the mold. Is it considered as load-bearing in the structure, or at least considered as concrete cover for the reinforcement?
Is it considered as the concrete cover,
okay,
but it's not load-bearing?
And so, do you have any plans to change this, any ideas to bring it into the structure as a load-bearing material?
Our test showed that the cracks in the concrete, in the load-bearing concrete or in the poured-in concrete, and of course in the printed concrete are the same. That would mean that they work together. But right now we cannot use the higher performance of the printing concrete in these load-bearing questions.
And the second one, do you have to secure the printed molds in the concrete, or is it just hold by friction between the two concretes?
During the construction phase, or?
No, in the service phase. Is there not the danger that they are falling off, the mold elements?
No. So all our tests showed us that they are not falling off after 120 minutes of 1000 degree centigrade firing. So there was some elements that fall down, but it was no collapse. And I think the bond is, so we tested the bond, and the bonding between these two concrete hybrids is perfectly.
Nice, thank you.
Hi, thanks for the presentation. I think you bring up a very nice point that you said that we wanted to test our ideas on actual building projects, and that of course brings building regulations into the conversation. So it's really nice that you show all the custom tests that you've been doing, structure and fire and so on. But I'm wondering, like, from a larger perspective, do you think there is any way to not have to do a custom test every time anyone needs to 3D print anything in a building? And what's the way that these would be integrated within the regulations of the building code in a more general way, the same way that we see standard elements having not to be burnt every time you need to use them in a building?
That's a super important question. I think all of us are suffering a little bit that there is no regulation, no standards. We are now discussing about. So what is a good one printed element? So think about. I mean, there are around 900 elements coming to the construction site. So all of them should be safe, and it should be clear that they are the good ones and not the bad ones. And so when we would like to open the field for architects and engineers in these design stages, we have to do a lot that we get control about the material and the process, and in the end the engineering for that. And we work on some standardization that we know more about the material. And I think all of you know that when you do mechanical testing on small pieces, that is depending on the size of the element, and there is no common agreement about what is the good test for especially additive manufactured elements. And there is, I think, for the next year a lot to do, that we bring it in this world and it is not separated from them, that we have always to test things. One way or one strategy is do a combination of well-known reinforced concrete work and 3D printed elements, because we sleep very well with this kind of construction, because it's completely in all our standards and all in our regulations. And it's just a question if there is some printed elements, can they fall down or not, or do we change any properties concerning building physics when we came up with this old idea of ripped slabs that we built in the 60s and in the 50s, or in the 1920s, these super early concrete slabs. We found one in Vienna, and we did this calculation for the CO2 equivalent, and they are much better than that what we can do now. And we have a lot of trouble, some of you know, that we can recalculate this early concrete work, but it works for around 100 years. So we are in discussion, is there some failure in our thinking about design or what? And we have to do this discussion for the next years.